This is your presenter Asloop Mudassar, and I am presenting slide number 17 of the course on laser physics. Question: what are the pumping rate equations for 3-level and 4-level laser systems? Answer: let us assume that N1 is the population of the ground level for 3 and 4 level laser systems. Assume that all the upper levels in 3 level and 4 level lasers are initially empty. The rate at which the upper laser level 3 in a 3 level laser becomes populated by the pumping process is given by equation 17.1. So this is, you see that the rate of change of N3 with time due to the pumping P is equal to W3G, which is the rate of pumping to the level 3 from the ground, times N1. So on the right hand side you see that we have N1 is being pumped with the pump rate, which is W3G, to the level N3. So the population of the level N3 will increase. So that is why this is the rate of change of the increase of a population of the level N3, and that depends upon the pumping rate and also the population of the level 1. In a 3-level laser system, the level 3 decays very quickly to level 2, and at any time the population of the level 3 may be considered to be 0, and the equation 17.1 takes the following form. So we can write, because the level 3 decays very quickly to level 2, so all the populations gathered in the level 3 is actually gathered in the level 2. So we can effectively say that the pumping is being done from the ground state to the level 2. So we have written dN2 over dt due to the pumping is equal to W3G into N1 as given in equation number 17.2. For the population inversion between the level 2 and the level 1 in the 3-level laser system, it requires that N2, that is the population in the level 2, should be greater than the half of the population in the ground level, that is N1. So N2 should be greater than 0.5 times N1, which is possible only when the pumping rate, which is W3G, is very high, depleting the population of the ground level by more than half. Now let's talk about a 4-level laser system. In 4 and quasi 3-level lasers, the pumping rate, which we designate as W4G, need not be very high, and the population of the ground level may be considered as approximately constant, that is N1 is equal to constant. The rate equation for the uppermost level due to the pumping process in a 4-level laser system is given by dN4 over dt due to the pumping is equal to pumping rate, which is W4G times N1. This is equation number 17.3. Level 4 decays very quickly to level 3 and effectively may be considered empty. The equation 17.3 may therefore be written as dN3 over dt due to pumping P is equal to rate of a pumping, which is W4G times N1, where N1 is the population of a level 1. So since the level 4 is effectively empty because the population decays very strongly, very quickly from level 4 to level 3, so we can write the above equation for level 3, which is given in equation number 17.4. Population inversion between the levels 3 and 2 in a 4-level laser system can be achieved relatively easily in comparison with a 3-level laser system. Thus we can write that the pumping rate for the 4-level laser system from ground to the 4th level is much less than the pumping rate for the 3-level laser systems pumping from ground to the level 3, that is W4G is much less than W3G. The equation 17.2 and 17.4 may be written respectively as given. So we have dN2 over dt for the pumping is equal to W3G times N1 can be written as R3P for the three level laser system, and the next equation, which is dn3 over dt due to pumping, is equal to 4 W4G times N1 is equal to R4P, and this is for the 4 level laser system, where R3P and R4P are the pump rates for a 3 level and 4 level laser system. The pump rates, which are R3P and R4P, must reach respective critical pump rate values, which are R3CP and R4CP, for the respective population inversions. So this is the end of slide number 17.